Welcome to this video. In this video, we're going to go through the first part of the data analysis exercise. The goal of this exercise is to put together all of the knowledge you have learned in reading and processing data with Python. Particularly, we're going to read the data from a file. This is a very important step, as data comes in different files and formats. We're going to focus on one popular format for data which is small in size. This particular format is called comma-separated value file, or CSV in short. This file comes with a data repository, so you can have access to it with the source code. This particular file has data about companies, their countries, market capitalization, cash, and revenue. Now this file, if you double click on it, chances it's going to open in Excel or your spreadsheet program. And this is because this file is formatted in a way that each row comes in one line and the columns are separated by commas, hence the name comma-separated value files. So you can operate on this file with a spreadsheet program, but in this exercise we're going to read the data to process it in the notebook. So let's switch to the notebook here. In order to read data from this file, we're going to use a package called CSV. So this package CSV is a package that comes built in Python and allows us to read CSV files, as the name implies. All right, so you have been given the code to read this file. So let us walk through it. So we have a list called data, and you can see that's a list because you've got the two brackets, so it's an empty list. And then you have a block of code here. As you see at the end of this block of code, we're appending to this list. So the goal of this cell is to populate the list with the data read from the file. So to read it from this file, we have what we call a with statement. This statement has a beginning that opens a file to read from. So here I'm opening this file, internetcompanies.csv, and I'm going to refer to this file as CSV file. Now next, what we're doing here, we are using the CSV package. And we're using a particular function from the CSV package called dictionary reader or dict reader. This means that each row in this file is going to be read as a dictionary. So then we're going to go over each row in our reader. So each row is going to be a dictionary, and we're going to append this dictionary to the list. So once this code runs, you will see that data here has been populated. And you can see that it has 20 records. That's basically the number of records in this file, right? 21 lines, and the first line is the header line. So we have 20 records. This format in which each record in a spreadsheet is a dictionary in a list is called a list of records. And it's a popular format to store structured data, tabular data in Python. Okay, now if you look at this data, you see that we've kind of read the data verbatim into our list. But it's still far from being useful for analytics. And one of the reasons here is that although we've got numbers, those numbers have been read as string. And you can see that by looking at the quotes, right? And obviously those numbers have non-numeric characters. We have the $sign and we have spaces. So that's one problem with this data. You also see that this data contains some missing values. So for example, not all of the companies are publicly listed, so hence we don't know the cash and revenue for some of the companies. For example, if you take a look at Uber here. So missing data is an interesting topic, and it's kind of a tricky aspect of data to deal with because there is no standard format to representing missing data. As you can see here, you see that this file has been using this $dash to represent the fact that the data point is missing. There could be other idiosyncrasies when we are reading files, especially files that have been kind of exported from different programs, or even worse, entered by manual operators who commit some inconsistencies and mistakes when entering this data to the program. So the first part in any data analysis pipeline is to extract the data. This process is often called as ETL, which stands for extract, transform, and load. So we want to extract the data, we need to transform it, doing some transformation, and load it into a data structure which is amenable for analytics. So you can see here in part 1, we have the following task: to convert market cap, cash, and revenue from string to integers. And we note that in this particular file, those numbers are giving in millions of dollars. So we need to multiply the value by 1 million. And then we are asked to replace the missing value with none. So none is a special value in Python, and we're going to use it to indicate a missing value in this data. So what we need to do then, after doing so, to test our work, we need to show the first record and the last record. Okay, so let's get started. So in order to deal with this data, I'm going to simplify my work by focusing on one record. Now, once I figure out how I process a record, I can process the whole data set using a list comprehension, because the data set is a list of records. So what we have in here, we have a record which is a dictionary. Now the first step is to convert each one of these fields, market cap, cash, and revenue, to numbers. So since this process is the same, I'm going to try to work on only one number, right? And then I'm going to isolate this code in a function that I can use to process the record. So let's take a look at one of these numbers. I'm going to call this one N1, and let's look at market cap here. All right, so we need to do a couple of things. We need to take out the leading and trailing spaces. Then we need to take out the leading dollar sign, and then we need to multiply by 1 million. So then you need to look at the string function that we learned about. What functions is useful to taking out the leading and trailing space? Feel free to pause this video to figure this out. So the function that takes out the leading and trailing space is the strip function. If you call on n1.strip, that's going to take out the leading and trailing space. Okay, so the next step is then to take out the dollar sign. There are a couple of ways of taking out the dollar sign, and once again, you can pause a bit and think about it. One way to doing it is to do a replace the dollar sign with an empty string. The other way to take it out is to realize that once we strip out the leading and trailing spaces, the dollar sign is going to be the first character in a string. So what I can do, I can slice my string from the second character onwards, and that's going to take care of the first character. So what I'm going to do here, I'm going to slice from 1, right? Because I want to go from 1 to the end. That's going to give me a number, 547. Now the next step is to multiply by 1 million. Now there is a trick in here, and I think many people will be kind of inclined to say, okay, I'm going to multiply this by 1 million. And I'm not going to run this cell. The reason is that this is a string, and if you multiply a number with a string, you're gonna get the string repeated, right? So it's gonna dump a very large string on the screen. Let's say what happens if I multiply it by 2. You can see here that this thing now is 547, 547, right? Which is not what we're looking for. So instead, we need to convert this to an integer, right? So to convert this to an integer, we're going to use the int function on the string, right? And that's going to give me 547, right? And then once this is done, I can multiply by 1 million. And that's going to give me 547 million. All right, so we figured out how we do it on one value. So what I'm going to do now, I'm going to write a function. Let's call this function convert to number. And this function is going to take the string which we called n1. I'm going to call it string. Avoid using reserved keywords. If you see anything highlighted in green, this means it's reserved, so don't use it. Let's call this one string or text. Doesn't make a difference here. Text. Let's call it text. And I'm going to return this as a result, right? So now if I do convert to number n1, that should give me the desired outcome. Now let's take a look at data 0, right? Because data 0 has a couple of other numbers. So let's try it on cash. So we can do this on cash, and that should give me the cash converted, right? So this function is taking care of converting the string to number, but we're not done yet because we have the missing values. So let's take a look at the last record, and the last record actually contains a missing value, right? The cash here is incorrect. So if I try to do it on data -1 cash, chances I'm going to get an error because the moment you strip in the $sign, you're trying to convert this thing to a number, and the minus sign is not going to give you anything, right? So you cannot convert this dash or minus to anything because it's not a number. So we need to fix our function. And we need to do this set of transformations step by step so that we have a chance to test whether we have a dash, and then we can return none to indicate a missing value. So I'm going to do it in multiple steps. So step number 1 is to keep it as a string, take out the leading and trailing spaces, and take out the leading $sign. Now, what I'm going to do here, I'm going to plug in an if statement. If step 1 equals to dash, that means I got myself a missing value. So I'm going to return none in this case, as the question has asked us to do, right? Return none. If this is not the case, I'm going to return 1 million times int. Now, int of what? Int of step 1, which is now guaranteed not to be a dash. Okay, so let's try that again on cache. And this one returns none, doesn't show anything, which is fine. That's what we were expecting, because none doesn't show, Jupyter doesn't re-echo a none. But if we try this one on 0 or 1, we should see a number here coming up. Okay, so that's very good. We managed to do it on one number. Now let's kind of tackle the record things. And again, I'm going to use the same pattern here. I'm going to simplify my thinking by just focusing on one entry. Let's call this entry R for record and see what's going on in here. Well, now we need to convert this to another record that has company country, but market cap has to be number, cash has to be a number, revenue has to be a number. So there are a couple of ways of doing this. We can actually override market cap. So we can say, okay, R of market cap equals convert to number R of market cap. Or we can create a new dictionary and then populate it with company, country, and then the conversion of market cap, conversion of cash, and conversion of revenue. I'm going to adopt the second approach because I want to keep the original data intact in case we want to refer to it. So what I'm going to do here, I'm going to create a new dictionary called T. And the end of the process, I want to show T, right? Right, T is now empty. So what I want to do, I want to set T of company, right? T should be the transformation of R. And company, we're not doing anything here. So I'm going to simply type company. Right, if I run and show it, it will show that T company is Apple. Right, so I'm going to do the same for country. And this is going to be R of country. Now here is the interesting thing. When it comes to market cap and cash and revenue, I'm going to use my function convert to a number. So T of market is going to be convert to number, which is the function I wrote of R market cap, right? It's not market, it's market cap here. So we're going to keep the same conventions here. So let's test and see what we've got. It looks like it's working correctly here, right? So that's very good. So we have converted market cap from, actually it's not, right? So let's take a look at this problem here, right? So it's always good to check what's going on. So what's going on in here is that we don't get this one multiplied by 1 million. And just looking at the function, the reason here is that instead of calling strip on text, I called it on N1. So that's a very common mistake when you isolate code into a function. So this is a learning experience to test the function multiple times and ensure when we isolate code into a function, we use the corresponding parameter name. All right, so good that we caught this error early on. Now we run the code and we see that it's giving us the correct number. Excellent. So let's do that for cash and revenue. I'm going to copy and paste this one here. And again, be careful not to commit a copy and paste mistake. So T of cash is going to be the conversion of R of cash, and T of revenue is going to be the conversion of R of revenue. All right, so let's take a look at R and let's take a look at T. It looks like we managed to convert that record properly. What I'm going to do, I'm going to test it on another record which contains a null value or a missing value, not a null value, a missing value which we want to convert to a null, the dash here, right? So I'm going to do the same. Now R is this one, and notice that cash and revenue are none as expected. All right, excellent. So we've managed to solve it on one record. I'm going to isolate the code into a function. So what I'm going to do here, I'm going to create the function convert record, and this will take record as a parameter. And I'm going to copy this code, paste it here, make the correct indentation, right? Make sure to return T at the end of the function. And crucially important, make sure to replace R with record. Otherwise, we end up with the same mistake that we committed in the previous function. I'm going to test my function again. I'm going to convert record data -1. Let's take out of R here. It looks like it's working, and let's convert record data 0. All right, so it looks like the function is working fine. So we have created two functions, one that converts a number and one that converts a record, and the one that converts the record uses the one that converts the number. The final step is to convert the whole data set, because we've got a list of records here which contains 20 records. So what we need to do, we need to call the function convert record on each one of the elements in this list. So there are two ways of doing this that we learned about. Either we use a loop or we can use a list comprehension. So let's look at using a loop. To use a loop, I'm going to create an empty list, which is going to be the result of converting data called data2. Then I'm going to go over each record or each row, each record in data. And then let's call this one T record. The transformation is going to be convert record of record, right? And then don't forget to append that to data2, T record. Once you do so, data2 should have the transformation here, right? And length of data2 should be equal to length of data. So if we do length of data 2, it should be 20 as well. So that's to double check that we've got that correctly. All right, very good. So let's see how we do it in a list comprehension. A list comprehension is basically a way to compact this loop in one line. So we need to have an iteration over a list, which is for record in data. And then we need to use the function here to transform record. So that's basically convert record of record for record in data. That, simply speaking, is going to give us a new list which we can assign to data2 as well. All right, so we have converted each record in data, and the list comprehension is going to give us a list. Now, again, I want to emphasize the thinking process here. When you have a complex problem, try to break it down to smaller pieces. And that's what I have done here. I had the problem of transforming a dataset. So I broke it to pieces, which is converting a record in the data. And converting the record also involved converting numbers. So that's another piece, which is convert number. I worked on the smaller piece and then isolated in a function. And then I worked on the second piece, which is converting one record, and then I isolated in a function, and then I use this function to convert the whole data set. This approach of thinking is called divide and conquer, and it's an effective way for problem solving. Now let's finish by doing showing the first and the last record, just for the sake of testing this work. So the first and the last record in data2 are going to be data2 of 0, right? That's the first record. And the last record is going to be data2 of -1, right? Either data2 at 19, because we've got 19 records, or much easier, go backward with the negative indexing. It's going to be data2 at -1. And that's the last record in the converted data. All right, so now the data is converted. We've got numbers, and we are ready for the second step. And the second step is going to ask us to do some analysis, some computations based on the data that we loaded and converted.